In the second half of Chapter 12, we moved from discussing surface area to volume. So I'm going to go ahead and write up a couple formulas that are going to be important for you guys to remember for the test. So when we talked about volume for spheres, we needed to take the area of the base. So this is going to be an area. Each of those bases are going to have different formulas depending on the shape, whether it is a triangular prism or whether it is a rectangular prism of some sort. The area of the base may have a different formula just depending on the shape of the base. And then you multiply that by the height. It is very similar for a cylinder where you are taking the area of the base. However, the base every single time for a cylinder is always going to be a circle. So you can automatically replace the formula with the b as pi r squared, because that is the area of a circle. So that can be pi r squared h. And it's going to be a similar process when we move from pyramids to cones. Now, the volume for pyramids is v equals 1/3 your base times your height, and that's because if you kind of have a cube and you're trying to make a pyramid, you're getting rid of a couple pieces. So that's where the 1/3 comes from. And just like prisms and cylinders, the formula is the same. Alright, the formula is the same for pyramids and cones, so it's 1/3 base times height. However, every single time for a cone, the base is the exact same shape, so I can automatically replace the area of the base with the formula pi r squared. And for spheres, we actually have two different formulas that we'll be looking at. We will be looking at volume, which is going to be 4/3 pi r cubed. It's a volume, so it's going to be cubed. And then we are going to be handling surface area of spheres in this section as well, which this is 4 pi r squared. And it is squared because we are talking about an area, not a volume. Now I'm going to move on to a couple of the examples that we did during our review. And if you're wondering where these are located, this is starting on page 858 of your textbook. I did tell you guys that I wanted you to do number 6, however, I wanted you to take the volume. So first I have to recognize what kind of figure this is. It is not a pyramid because I have a couple of bases that are parallel. I have multiple bases actually, and they don't all meet at one nice point like a pyramid does. So this is actually a triangular prism, so I'll be using v equals bh. So now I need to recognize it's a triangular prism, so I need to find the area of the base. And the area of the base is going to be the formula for a triangle, so 1/2 base times height. And that's going to be 1/2 6 times 7, which this is 42. So 1/2 of 42, which is 21. So that replaces my b. So v equals 21. And then I'm going to be multiplying that by the height. Even though this looks like length, my prism is laying on its side, and 10 is the height of the prism. So I'm going to be multiplying that by 10. And I will get 210 miles cubed, since it is volume. And that is going to be my final answer. Next question. For a cylinder, I can go ahead and use BH, or pi r squared, h, because this base happens to be a circle. So I need to find r and I need to find h. H is 15, and r, I'm going to put pi out here in front, r is 12, so 12 squared. We should know that 12 squared is 144. Times 15. And then I did tell you guys to actually start using your pi button and round at the very last step. So I will be doing that. I'll be taking pi times 144 times 15, and I will get 6,785, and I'll go ahead and say round to the nearest 100th. So that's 2 decimal places. This does give me 840, and that 0 would round to that 4. It would round down, and since it is volume, it is feet cubed. Next, I have a prism again, so I'll be using volume equals base times height. So I need to find the area of my base. The area of my base is going to be found by multiplying 1.5 times 2.1, and then I can replace that height with 3.6. So then when I multiply all of these numbers together, I am going to get 11.34, and I'll say round to the nearest 100th, and that'll do. And this is a volume, so it should be meters cubed. The next question gives me, I believe this is number 16, gives me different pieces of information. Alright, so I need to see what they give me. They give me a diameter and they give me a height. And it does say the volume of a cone, so I'm going to need V equals 1/3 base times height. And since it's a cone and my base shape is a circle, I can use pi r squared h. So I need to figure out r and h. Well, I'm given the diameter, so I would just chop that in half, and the radius should be 8. And so I'll be able to replace 1/3 pi times r squared, which is 8 squared, so that's 1/3 pi times 64, and multiply that by my height, which is 15. Now you can go ahead and do a little bit of math before you put it into a calculator, or you can multiply pi times 64 times 15 and then divide by 3 at the end, or you can take 1 divided by 3 and then you would enter that, and so you would have the value of 1/3 times pi times 64 times 15. Or you can go a step further here, and instead of dealing with the fraction in your calculator, you could realize 1/3 of 15 is 5, so I'm left with pi times 64 times 5, and put that into a calculator and round to the nearest 100th and get 1005 point, it does give me 309, so that would round up to 31 centimeters cubed since we are looking for volume. And in any of these problems, I should be able to plug in these pieces, the base and height, the radius, height, and be able to find the volume. I also need to be able to rearrange these problems in order to solve for one of the other pieces if I were given the volume. So number 17 says the volume of a pyramid. Alright, I don't know what kind of pyramid, however, it doesn't matter. So the volume of a pyramid, so I should be using 1/3 base times height, and they give me the volume, alright, and they also give me the height and ask me to find for the base. So I plug in what I have, and I'm left with one variable, so I should be able to solve. So we can handle this a multitude of ways, one of which, so option 1, I can go ahead and take 1/3 of 15 and get 60 equals 5b. Or, in order to get rid of the fraction, option 2, you can divide each side by 1/3, and that would, in fact, get rid of that, and you'd have to divide 60 by 1/3. And if I were to do this over here at the side, 60 divided by 1/3, when you divide by a fraction, that's the, keep the 60, change the sign, so I'm no longer dividing, I'm multiplying, and you flip. Keep, change, flip. So I flip the bottom, so I would get 180 equals 15b. Or you could see that in order to get rid of this fraction, you could multiply each side by 3, and the 1/3 would drop out, and option 3 is multiply instead of dividing by the fraction, and you would still get 180 equals 15b. Alright, now I'm going to go ahead and pursue option 1 since the numbers are a little bit lower. I would then divide by 5 and get b equals 12. Now I have to keep in mind that what does b stand for? B stands for the area, so it should be inches squared, and that is my final answer. The next couple of questions had a couple people in a little bit of panic during class because they came out with such big numbers. And that would be because when you look at the problem, it's dealing with Pluto. It says the shape of Pluto. And if we're talking about the planet and the surface area and volume, it's probably going to be a big number. So don't worry when it comes out to a big number. So if I'm looking to find the surface area and the volume, they give me the diameter. And for surface area, that is 4 pi r squared. And then volume, I should be using 4/3 pi r cubed. In order to find these, I need to know what the radius equals. That's the only piece of information that I need. So I'm going to be chopping the diameter in half, and I will get equals 1,195 kilometers. And then into each of my formulas, I'm going to plug that in. 4 pi, and I'm going to need to square this number, so I'm going to end up with a rather large number. And for volume, 4 divided by 3. Now we've discussed how to deal with this fraction right here, 4/3. We could multiply by 4 in the beginning and then divide by 3 in the end. Or you can find the value of 4/3, so you would get 1.3333333333, and then multiply that by the pi r cubed. Alright. And when I do this, I should end up with the values if I type it in correctly. And my suggestion would be typing in this number first and then multiplying by 4 pi. Dealing with your exponent first, so I would deal with the exponent first. And you guys did ask how to type that into your calculator, because you guys do have squared buttons, so that's nice. However, for something like this one, where you have to the power, you would type in your number, and then you would find the caret button, and that means raised to the 3rd power. And that would give you your value. So you would find that, and then you would multiply it by pi, multiply it by 4, and then divide by 3 in the very end. And for these two values, you should end up with 17,945,091. This is area. Remember, surface area is going to be kilometers squared. And for volume, I should end up with 7,148,000. Oh, sorry, that was 7,148,128,073 kilometers cubed. So please remember your order of operations, PEMDAS. So my suggestion is dealing with your parentheses or your exponents here, your little group, and then dealing with multiplication afterwards. Alright, the next problem. It involves adding a couple of volumes together. So it says that a solid is composed of a cube with side length of 6 meters. Alright, so that means if it's a cube, the base is 6 by 6 and the height is 6. And then it says on top of that there's a hemisphere. So a half of a sphere. So I'd be finding the volume of a whole sphere and then chop that volume in half, and that would give me the hemisphere. With the diameter of 6 meters. So it's just laying right on top of the cube there, and it has the diameter of 6 meters, which means it has the radius of 3 meters. Alright, so find the volume of the entire solid. So what are you going to do? You're going to be finding the volume of the cube, and then you need to find the volume of the hemisphere. And you need to add those two pieces together for your total volume. Alright, so the cube is fairly easy to deal with. The volume of the cube is the area of the base, which is 6 times 6, times the height. We know that with cubes, what you can do is take the side length and raise it to the 3rd power, and that's going to give you 216 meters cubed. Alright, so that's going to fill in 216 plus Now I need to find the volume of the hemisphere. So you're going to be using the volume of the sphere formula, which is 4/3 pi r cubed. However, in the very end, since it's only a half a sphere, you need to chop it in half. Alright, so let's plug this in. I'm going to have 4/3, 4 divided by 3, times pi, times r cubed. R cubed, 3 cubed, is 27. And then in the very end, I need to chop that in half. So, I'm going to take 4/3 times 27, and 4 divided by 3 is what I'm going to type in my calculator, and then I'm going to multiply that by 27. So I'm going to get 36 pi over 2. 36 divided by 2 is 18 pi, and so that is going to give me a total of 56.548. If I were to say to round to the nearest 100th, I would round that 8 up, and that would be 55 meters cubed, since this is a volume. So I'm going to be adding 216 to that, so 56.55. And so your total is then going to be 272.55 meters cubed. Alright, now let's handle our last section, which would be 12.7, and how we find the ratio of areas and volumes. I chose 22 because the scale factor 2/5 is the most complicated out of the three, and we'll be dealing with the biggest numbers. So when we were talking about scale factor before, we're comparing two figures or two solids. So a scale factor is just A over B. So our scale factor is 2/5. Now when we are dealing with surface area, we need to square those because area is squared. So that's going to be 4. 2 squared is 4, and 5 squared is 25. If we're dealing with volume, volume is cubed. So I need to cube A cubed over B cubed. Alright, so that means I need to do 2 times 2 times 2, which is 8, and 5 times 5 times 5, which is 125. So we're going to be using each one of these if we're talking about surface area or volume. And we're going to use those to set up a proportion. Now, I have A over B, so if I ever set up a proportion, I'm going to have A over B and A over B. Alright, so those pieces need to be consistent. So what they give me is they give me the surface area of A and the volume of figure A. So I know that the ratio of the surface areas should be 4 over 25. And that is A squared over B squared. And they give me the surface area of A, which is 144 pi. Now they tell me I need to figure out what the surface area of B is. So this is your missing piece, and this is what you need to find. So what are you guys going to do? You're going to cross multiply and then divide. So you would get 4s equals 144 pi times 25. And before I multiply, I want to go ahead and solve for s. So this is the surface area of B, and I would divide by 4. So 144 pi times 25 divided by 4. And if I do a little bit of math here before I grab my calculator, and I decide to reduce the top and bottom by 2, I can chop 144 in half and get 72 pi times 25. So I reduce that by half, and then reduce the bottom by half. And if I divide by 2 again, from the top and the bottom, I would get 36 pi times 25, and 2 divided by 2 in the bottom would just give me 1. So if I type that into a calculator, I should get my final surface area for B to come out to 900 pi yards squared, And if you chose to multiply through with the pi symbol, you would get 2,827, and I would more than likely tell you guys to round, and that would give you 43 yards squared. Volume is a very similar process. However, instead of using the a squared over b squared, you're going to be using a cubed over b cubed. Alright, now let me finish writing this up. Yards squared. So for the volume, I have a over b. So this is 8 over 125. And I have the volume of a, so that should go on top, 288 pi over what I don't know. So you can replace that with your variable x, or you could replace it with v of b. So the volume of the solid b that we are looking for. And you could, of course, cross multiply and divide. So you're going to get 8v equals 125 times 288 pi. You could then divide by 8. So v equals 125 times 288 pi divided by 8. And that would result in 4,500 pi. It is a volume, so this is yards cubed. And if you decide to go ahead and multiply through by the pi symbol, you would get 14,137.166, which would be 17 yards cubed. And that is how it sets up. So you need to figure out mainly, if we're talking about surface area, you need to use a squared over b squared. And if you're talking about volume, a cubed over b cubed in order to set up that proportion and solve for the missing piece.